So in the previous video, I talked about how there's two different units that we will use to measure angles in this class. They are degrees and radians, which we defined in the previous video. And the big takeaway was, for example, a 45-degree angle is the exact same as a pi/4 radian angle. They're just measured with different units. I could say that I'm 75 inches tall, or I could say that I'm 6¼ feet tall. It doesn't matter, it's the same height. I'm just using different units to express my height. But having two different units to measure the same thing is a bit problematic. We're going to want to go back and forth between the two. The purpose of this video is to give you a short way to convert from degrees to radians and radians to degrees. For example, if I had a 60-degree angle, but I didn't want to measure that angle in degrees, I wanted to measure in radians. How many radians is a 60-degree angle? Well, the trick to conversions is you always want to multiply by 1. Because if I multiply 60 degrees by any number other than 1, I'm going to change this thing. But I don't want to change this thing. I don't want a different angle. I want an angle that's the exact same as this thing. I just want to use different units to express it. So anytime you're converting units, angle units in this case, you can only multiply by 1. But you want to pick a special form of 1. You want to express 1 as a fraction. And the way you express 1 as a fraction is you put something that is equal to something else on the top and the bottom of that fraction, right? 5/5 is equal to 1. 27/27 is equal to 1. As long as the top and the bottom of the fraction are equal, then the fraction itself is equal to 1. And as long as I'm just multiplying by 1, I'm not changing the value of this thing. So you're like, all right, is it 5/5 or 27/27 that you're going to multiply this by? Well, neither actually. My unit is currently degrees. I want to switch it into radians. So what I have to do is divide by degrees and multiply by radians. You can kind of think about this 60 degrees as 60/1. Degrees are up in the top of the fraction, so I have to put degrees down on the bottom of the fraction so I can cancel those units, and that will leave me in radians. So I want some number of radians divided by some number of degrees to switch from degrees to radians. How many radians, how many degrees? Well, it doesn't matter as long as the number of radians and the number of degrees represent the same angle. So I could take pi/4 and 45 here, and that would work totally fine because pi/4 radians is the same as 45 degrees. I could take 2 pi radians at 360 degrees, and that would work totally fine too because 2 pi radians is the same as 360 degrees, so I'm just multiplying by 1. To make the math work out as nicely as possible, what we'll do is we'll choose 1 pi radians, and then it's equivalent in degrees. Let's see, 1 pi radian was halfway around the circle because 2 pi was all the way around the circle. So what is halfway around the circle in degrees? Well, 360 degrees is all the way around the circle, so halfway around would be half of 360 degrees, in other words, 180 degrees. The conversion factor that we will use anytime we're trying to switch from degrees to radians is we're just going to multiply by pi/180. What I'm saying is 60 degrees is the exact same as, let's see, degrees would cancel out, and I'd be left with 60 pi/180, and now my new unit would be radians, because again, this is gone, and I'm left with just the radians. Typically, people don't say 60 pi/180 radians. They reduce this fraction. 180 is 3 times 60, so I can reduce this to just pi/3 radians. And what I've just done is I've converted degrees to radians. To see if that made sense, see if you can express 135 degrees in radians. Well, same logic. I got 135 degrees. I can think about this if I want as 135 degrees over 1, if that helps you. You don't have to write that. And then I'm going to multiply it by pi/180. Pi is radians, 180 is degrees. Degrees are on the bottom because degrees are on the top up here, and I want to cancel those out. What I'm left with is 135 pi divided by 180 radians. Technically, we should reduce this fraction. Right now, you might not be at the point where you can reduce that really easily. It'll end up being 3 pi/4 radians. The reason this reduces so nicely is because 135 is 3 times 45 and 180 is 4 times 45. And if you recognize that, great, but I'm not super concerned with that. If you got this far, then you're like, yeah, and reducing fractions, fine, that gets me here. Okay, but what if I was going in the other direction, right? Now I know that 60 degrees is equivalent to pi/3 radians. But what if I started out with pi/3 radians and I wanted to convert that into degrees? We know the answer should be 60 degrees, but pretend you don't already know the answer. Suppose you just started out right here. Well, I need another conversion factor. I'll take my pi over 3, and my unit is radians, and then I'll multiply that by the number 1, because if I multiply by any other number, I'll be changing the value of what I have here, and then I won't just be converting my units, I'll come up with a whole different answer. So it's important that this conversion factor equals 1. And you're like, yeah, pi over 180, we already went over this. No, you don't want pi over 180, because pi is in radians, and this thing is already in radians. So think about radians as the unit up on the top here, just like degrees was the unit up on the top here. I want to get rid of radians and turn this into degrees. So I need radians to be down on the bottom and degrees to be up top. I could still choose any two equivalent measures that I want, but again, the easiest one will be 180 degrees divided by pi radians. What I'm saying is when you're converting from degrees to radians, just multiply by pi over 180. When you're converting radians to degrees, all you got to do is multiply by 180 over pi. It's not a bad idea to write out the units in each of those the first few times through, but pretty soon you'll get so good at these that you won't even be writing the units and you'll know exactly where everything goes. Let's see how this works out. I'd end up with, if I multiplied straight across, 180 pi divided by 3 pi, and what would happen to my units? Let's see, the radians that this is written in, and this radians would cancel out, so I'd be left with just degrees. I'd have 180 pi over 3 pi degrees, but I can reduce this fraction. The pi's cancel out, and 180 divided by 3 is just 60, so what I'm left with is 60 degrees. Similarly, 3 pi over 4 radians. I won't even write radians. We'll assume that we can figure that out just from the context. What I would do is I'd take that 3 pi over 4, and I would again multiply by 180 divided by pi. I'm not even going to put in the degrees here. From the context, I'll be able to tell what I'm talking about. And then I multiply these together. You could multiply straight across if you want, or you can cancel out this pi and this pi. And then if you recognize that 180 is 4 times 45, you can cancel out this 4 and a 4 from up here, and what you're left with is just 3 times 45, which is 135, our measure in degrees. For what it's worth, I'm not too picky with radians. I think we can tell from the context when an angle is measured in radians, but it's a good idea to always denote degrees. And then what we can tell ourselves is if we're talking about an angle, we'll know that the angle is measured in radians unless it explicitly tells us degrees. So keep this symbol for degrees, and then if nothing's written, we'll assume radians. These first few times through, though, if you want to write radians so it can help you with canceling out the units with these conversion factors, that's fine. The big takeaway here is this. Anytime you're trying to convert from degrees to radians, all you're going to do is multiply your measure in degrees by pi over 180. And anytime you're trying to convert radians to degrees, all you're going to do is multiply your measure in radians by 180 divided by pi.